I'm Stephanie Griebel, a PhD candidate in plant breeding and genetics at Purdue, and I'm very passionate about teaching the next generation scientists, students in plant breeding and genetics. So far, I taught the genetics laboratory in agronomy for 3 semesters, and currently MTAing with my major advisor, plant breeding and genetics. I enjoy it very much to see how my students grow from the beginning to the end of the semester. Part of my teaching philosophy is retrieval practice, because I believe reviewing the key concepts several times using different technologies, trying to reach different students' learning styles helps the students to deepen their knowledge, have a better learning experience, and retain the knowledge for a longer time. Having a more student-centered learning environment using active and experiential learning techniques like field visits, group discussions, or formative self-assessment cards helps the students to stay engaged, retain knowledge, and be prepared for their future career. So today we are going to review a little bit for your final exam next week, and we cover chapter 21 and 22. And I would like to start with you on some low-stake assessment question, because we talked about the topics, and I hope that you remind some of the stuff. So let's use our self-assessment cards. You know how they work. So quickly remind you about it. You will take a coin, and each question on the self-assessment card relates to a question on my PowerPoint presentation. So, for example, question 1 has 4 different response options, A, B, C, and D, which is also an option on your self-assessment card. It's A, B, C, and D. So please take one of these coins, and you can choose what is the answer. Is it A, B, C, or D? Then you scratch off the field, and if it's the correct answer, you will see a star. You can assess yourself with 5 points and write it on the right side. If it's wrong, it's not a problem, just give a second try and maybe you get 3 points. And you can keep continuing on until you find the correct answer, and then we discuss about it. Question number 2. If you would like to create a mapping population, what do you need to do? Do you need to select parents which have no variation for your trait of interest? You cross and you develop your desired population. B, you can use a sorghum diversity panel, for example. C, you are selecting parents having variation, you make your crosses, you develop your population. Or D, none of the above. It's very, very important that you select parents that have variation for your trait of interest. High yield and low yielding, for example. You need genetic variation. You cross and then you develop your population of interest, maybe an F2 population, a recombinant inbred line population, or a near isogenic line population. C. So if you remember when we talked about it, if you create an F2 population, you are crossing 2 parents, you have that F1, yourself, you have F1, you have your F2. So you have not much recombination going on in comparison to a recombinant inbred line population, because you're selfing your F2 lines over several generations. So in your recombinant inbred line population, you have way smaller linkage blocks. Due to the selfing, due to the recombination, you are breaking down these huge blocks into lots of small ones. And this is desired. Do you need a mapping population, or could you use a sorghum diversity panel? The correct answer is B. I would like to talk to you now about a genome-wide association study we did in class and in your homework assignment, and I would like to group you up, because I want to talk with you about how can we find marker trait associations and how do we practically do it. So I want you to group. For group number 1, it's the question about what are typical populations and input data for GWAS group. For group number 2, do we need to account for certain information? Here I would be happy if Robert and Peyton and Carsten could be group number 2. Group number 3, a general linear model needs which type of data? So I would like you to take a few minutes, and I would be happy if group number 1 could work here at the board. You can take the big white papers. Here I have pens for you. You can take notes to answer your questions, and then we will discuss about it. Group number 2, 3, and 4 can go over here.
That's your handwriting.
Unstructured population. Somebody has lots of natural variation at the university. It's not like you have a fucking college where you're sitting also.
Native one. Oh, yeah.
Well, at least for our training.
What did you account for?
Population structure.
You mean in terms of like phenotype, genotype?
That's right.
So we said for populations, diversity panels, and not a mapping population.
So the key is that it's an unstructured population that relies on existing variation. It's not something where you're planning it out and making crops or something like that.
Except.
Yeah, we said yes. And the things you need to account for would be population structure, the kinship, and have diversity within the trait of interest.
That's correct. So basically, what is population structure and kinship? What are you calculating there?
Well, kinship is a relatedness between individuals and generally expressed in a matrix, whereas population structure is expressed in a principal component analysis.
Very good. That's correct. And now we know what we need to account for. So if we are building now our model for a genome-wide association study, what did you find out in group number 3?
So the general linear model combines the phenotypic data, the genotypic data, as well as the population structure, which is the principal component analysis, the PCA. Whereas the mixed linear model takes in kinship into account to add that relatedness for an association.
And group number 4, what is the most important or the key concept for GWAS?
So we determined that it's linkage disequilibrium, and this is just basically SNPs are in linkage disequilibrium when they are inherited together, and that's called like haplotypes. And what you want is that your gene of interest is in linkage disequilibrium with the SNPs, with some SNPs that you can detect by GWAS.
So please come here so that we have a look together on the last slide. The answer was correct. GWAS is based heavily on linkage disequilibrium. And what you see here on the slide, basically your genotyped SNP. Using active learning techniques like the formative self-assessment, cards or group discussions, creates a learning environment students really enjoy to learn. I got students' feedback and they told me, I really enjoyed it coming to class, doing these low-stake assessment questions. It helped me learn and it prepared me way better for the high-stake assessment questions in final exams.